bearing, basically what it does is, apart from supporting the rotor, it also helps to enhance the rotating motion, okay, that is expected from the electric motor itself. So the bearing is a very important component within the electric motor, because once it fails, the output, which is the rotating mechanical energy that is needed from the electric motor, cannot be obtained from the electric motor. So now, what are some of the conditions that can result to the bearing failure? The first, as you can see on the screen, is lubrication problems. That is, when we do not have enough lubricant in the bearing, okay, that can result to lubrication problems. So the installation and the installation procedures also, if standard procedures are not followed, the SOPs for the installations are not followed, precision installation processes, precision alignment and what have you, they are not followed, all of these can introduce problems that will affect the bearing at the end of the day. Then we also have misalignment, okay, that is when the center shaft of the coupling on the electric motor is not coinciding, or is not does not coincide with that of the load itself. Are we getting it? So it could be offset or angular. So this also can affect the bearing. Once you have misalignment, it can affect the bearing and cause bearing damage. Then we also have environmental factors, as we have said earlier. So the ambience, the humidity in this case, okay, or if the is an environment that is dusty, or an environment that have corrosive vapors, okay, corrosive vapors in the environment or atmosphere. So if all of this gets into the bearing, it will affect the bearing. Apart from initiating corrosion around the bearing, it can result to the lubricant losing its lubricating capabilities or capacity, as you can see on the screen. So aging too, that is, every bearing, they have a definite life, okay. So this bearing, if they are used according to how it is supposed to be used, if the operating conditions are right for it, the bearing will last for a very long time. But once they are exposed to stringent operational conditions, okay, more than what it is designed for, that will accelerate the aging of that bearing. If you are familiar with the bathtub curve, you'll see that that harsh operating environment will drive it into the old age region of the bathtub curve, where the potential or the probability of failure is usually very high. Okay, so those are some of the causes of bearing failure. Then once the load on the bearing is also too much, that is, the load on the bearing, even on the electric motor, that will be transferred to the bearing, okay, because remember, all load is transferred through the bearing, okay. So if it is too much, that will reduce the life also of the bearing. Then electrical issues, that can also result to shortage or a reduction of the life of the bearing. So if there are manufacturing defects, okay, if there are defects in the bearing, in the course of operation, that defect will be accentuated, and then that it will be increased, and then the bearing potential for failure will also increase. So still talking of the internal fault. We are going to next look at the rotor problems, because if we have faults with the rotor, that will also affect the operations of the electric motor. So we know that the rotor is the rotating member of the electric motor. And as we have said earlier, this rotating member is supported at both ends by the bearings on the shaft, as you can see. Okay. So now, what are some of the common faults that are associated with rotor? The first is the broken rotor. Broken rotor. So once the rotor is broken, you see that the magnetic field that is expected to be created on the rotor will not be properly formed. Okay, remember this conductive bar, around these conducting bars, magnetic field is created. Okay, so the summation of the magnetic field will eventually determine the strength of the magnetic field that will be created around the rotor. So once we have a broken bar like this, that will eventually reduce the strength of the magnetic field that will be created. So that will affect the efficiency of the electric motor. Okay, so another thing that can affect it too is when the bars, they are loose within the slot. Are we getting it? So once they are loose within the slot, you see that these are the bars. If they are loose within the slot, maybe because of poor handling and what have you, that will also affect the efficiency of the electric motor. Okay, then this is some of that is broken end ring. I was saying it because the end ring is meant to short all the rotor bars. This is the end ring. It's meant to short all these rotor bars or conducting bars on the rotor. Okay, so once it's broken, you'll see that it will not be properly shorted, which means that since it's not shorted, there will not be zeroing of the current that is flowing along these bars, and that will affect the efficiency of the electric motor. So another factor is the skewing of the rotor. Okay, so if you look at these rotor bars, you see that they are skewed. They are not straight. Okay, they are placed at an angle. So you see that during operation or because of maloperations or wrong handling, okay, during maintenance and what have you, that skew can be increased beyond what is normal, and that will eventually affect the operations of the rotor at the end of the day. So another factor that can cause rotor problem, as we have outlined earlier, is when the rotor is rubbing, probably because of faulty bearing, misalignment fault. Okay, faulty bearing or misalignment fault. So that will eventually force the rotor to be rubbing at one end. So apart from the fact that it is eating up the rotor bars and the yoke of the rotor, this is the yoke, it is reducing the effective size. And remember, this yoke is meant to concentrate the magnetic field, that is to increase the strength of the magnetic field in the area where you want it to actually be focused. Okay, so that will reduce it, and then once that happens, it can affect, even as you can see here, can affect even the stator because the rubbing is severe. Okay, it can affect the stator and cause stator winding short because the insulating material that is used to cover the slot could be eaten once it's rubbing, and then the possibility of the copper wire that is in the slot touching the rotor or coming out or shorting to the stator yoke itself will also increase. So rotor winding faults, that is for those electric motors that have synchronous electric motor that have windings in the rotor. Okay, so any of the faults that are associated with any equipment that have winding, short circuit, open circuit, what have you, okay, all of them can also affect this rotor winding. So there are some electric motor that have permanent magnet, as you can see on your screen. So this permanent magnet can lose their magnetization. So once they are demagnetized like that, the electric motor will not work. Are we getting it? So it's now left for us to determine the cause and then try to remedy them. In most cases, it is to change the rotor or to do a few amendments, provided we know precisely what we are doing.